Okay guys, so in this lab we're going to be discussing density. Okay, so density is going to be the ratio of mass to volume. Our mass is usually found by going to a scale, a triple beam balance, electronic scale, and it's always in grams. Our volume is usually in centimeter cubed or milliliters. So we're going to go through a few different techniques to find densities of liquids, densities of unknown solids, and finding the density of an irregular shaped object, okay? So as you read through the lab, make sure you read this for each section, okay, that we're gonna be dealing with. So the first section we're gonna be dealing with in the first part of the lab is gonna be finding the density of water, okay? So we're gonna weigh a clean, dry 100 milliliter graduated cylinder, record the mass on our data sheet. We're going to pour 60 to 70 milliliters of water into the cylinder and record the volume. And we're going to weigh the cylinder again, record the new mass, and then we're going to calculate the density of the water. Okay, so our first step is to weigh the graduated cylinder. It looks like it has a mass of 102.60. To add between 60 and 70 milliliters of water, and as you can tell, we read from the bottom of the curved line called the meniscus, so we got about 63 milliliters of water. Was to weigh the graduated cylinder with the water in it. Okay, so we get 165.96. Now, the way we get the mass of the water is we subtract 165.96 minus the initial mass of the graduated cylinder. So, from the video, we first measured the mass of the cylinder. So the mass of the graduated cylinder is going to go in this blank right here. Okay, we're going to measure out 60 to 70 milliliters of liquid, which we did from the video, and we should write that right here in milliliters. Okay, so we're going to go back and reweigh the mass of the cylinder and the liquid. We did that in the video, and so to find the mass of the liquid, we're going to subtract number 1 from number 2 to get the mass of the liquid. To find the density of the liquid, the density of water, we should get the mass divided by volume. Okay, so we're going to do number 3 divided by number 4. And we should get something really close to 1. Okay guys, so now we're going to go through the process for finding the density of a rubber stopper or an irregular shaped object. Okay, so we're going to get a rubber stopper and we're going to put it on the balance and we're going to record the mass in our data sheet. We're going to place about 30 milliliters of water in the graduated cylinder and record the reading. We're going to carefully transfer the stopper to the graduated cylinder, taking care not to splash any of the water out of the cylinder. Be certain no air bubbles are trapped, and record the new volume on the data sheet. Okay, we're going to calculate the density of the stopper to the nearest 0.01 grams per milliliter. Okay, so the next part of the lab deals with finding the density of a rubber stopper. So in order to find the density of a rubber stopper, we've got to find the mass first. So it looks like it's got a mass of 10.35 grams. Okay, so the next step was to measure out 30 milliliters of water. Now what we're going to do is we're going to find the volume of the stopper by water displacement, okay? So whatever the amount of the water goes up, minus the initial amount of water, which we had about 31 milliliters of water in it, is how we find the volume of the stopper. Okay, so we do this for any sort of irregular shaped object. Okay, and we're going to see what it goes up to now. Okay, it looks like it went up to about 38 milliliters. Once you've calculated the mass, which we got from the scale, and the volume that the stopper has by water displacement, you can calculate the density. Okay, going over a data table for our rubber stopper. The mass of the stopper we get from the scale. The volume of the stopper in water is the volume of the water line once I drop the stopper in. The volume of the water is the initial amount of water that I placed in the graduated cylinder. It's at about 30 milliliters. Okay. The volume of the stopper is found by subtracting these two calculations right here, number 2 minus number 3. That's water displacement, and we talked about that in lecture, okay? The volume of the stopper is how much the water is going to go up, okay? And so the density of the stopper is going to be the mass of the stopper over the volume of the stopper. Okay, so the next part of the lab is finding the density of an unknown solid. In lab, we have a big box full of blocks, different metals, aluminum, tin, brass, I think copper's in there also. But I just chose 2 for this lab for the video. So what you're gonna do is you're going to, it says obtain an unknown from the laboratory instructor, record the number of your unknown on the data sheet. Well, we just have 2 of them, so we're just gonna go with the calculations in our video. We're gonna measure the length, the width, and the height of the cube. Calculate the volume of the object, okay? So, volume of a cube is measured by length times width times height, okay? So, each of them should be the same because it's a cube, okay? So we get that from the video. We're gonna weigh the object on the balance, okay? Each one I weighed individually in the video, and you're going to calculate the density of the material by doing mass divided by volume. You're going to compare your calculated density with the density table provided on Blackboard and determine the identity of the material. Just a little hint, one of them is probably going to be aluminum, and the other, I believe, was brass, okay? So let's see how close we get to the actual density for those metals. Okay, the next portion of the lab is to calculate the density of a known solid, of an unknown solid. So I'm going to weigh my first block. Okay, I'm going to record the mass. Okay, so it's 85.63 grams. My second unknown solid has a mass of about 271.08 grams. Now, to get the volume of the solid, we're going to measure the length, the width, and the height. Block, we're going to measure using centimeters for all 3 sides. Now, as you can tell, it's kind of hard to hold steady and videotape at the same time. But the length is going to be about 3.1 centimeters. And this one is going to be about 3.1 also. Okay, going to our data sheet. Our first unknown solid we're going to write here. It's the silver one, silver looking one. Okay, we're going to write our mass here and our volume here. Remember, our volume is found by length times width times height. And our mass we get from the scale reading. Okay, so we can find the density by doing mass divided by volume. Now, our unknown solid 2 is the gold-ish looking one, okay? So we found the mass from the scale. Our volume is found by length times width times height. And we find the density of the unknown by doing mass divided by volume, okay? So we should get something close to the density of aluminum, and we should get something close to the density of brass. Thanks. Okay, so the last portion of our lab deals with the density of an unknown liquid. So our process is going to be the same as what we did with the density of water, okay? We're going to obtain an unknown liquid from your lab instructor, okay? So I obtained, I believe it was vinegar and isopropyl alcohol. So when we do these, it should get, we should have densities really close to those. Okay, so we're going to weigh a clean, dry 100 milliliter graduated cylinder. Okay, we're going to pour 60 to 70 milliliters of the unknown liquid into the cylinder and record the volume. Okay, we're going to weigh the cylinder again and record the new mass, okay, after we've added the liquid. And what we can do is we're going to subtract to get the mass, okay, so the mass with the liquid in it minus the mass of the graduated cylinder originally. That gives the mass of the liquid. And then our volume is going to be read from the graduated cylinder directly. So we can calculate the density of the liquid. And then we're going to compare the calculated density with the density table provided on Blackboard and determine the identity of the liquid. Okay, so the last part of this lab is to find the density of an unknown substance, okay? So an unknown liquid. So we're going to be dealing with liquid number 3 and liquid number 12. Now, just by smelling this, just a little waft, it smells like it's going to be vinegar. Okay, so we should get something really close to the density of vinegar. And this one, number 12, if I smell it, it smells like isopropyl alcohol or rubbing alcohol. Okay, so our density should be really close to those for vinegar and isopropyl alcohol. So what we can see is the mass, the graduated cylinder we're going to use for unknown number 3 is going to be 102.05 grams. The volume of the liquid is 45 milliliters. What I'm going to do is I'm going to go back to the scale and I'm going to weigh it. So I get a mass of 147.89. Now remember, the way we get the mass of the liquid, we subtract this mass right here minus the mass of the graduated cylinder. To get the density, you do mass divided by volume. We're going to repeat the same process for unknown number 12. It looks like it has a mass of 116.99 grams. Just like in the last portion of the lab, I measured out a volume of our unknown liquid, and it looks like it's right at 48 milliliters. Now, what I'm going to do from there is I'm going to go back to the scale and I'm going to weigh it. Okay, so I get a mass of 154.66 or 67 grams. Now, the way we get the mass of the liquid is by subtracting the graduated cylinder mass from this mass, okay? And then our volume was about 48 milliliters. So to find the density, we're going to do mass divided by volume. So this is unknown number 12. Okay, our data table after we've completed watching the lab video over this section. Okay, the mass of the unknown liquid we get by subtracting the mass of the graduated cylinder and the liquid minus the initial mass of the graduated cylinder. Our volume is read directly from the graduated cylinder in each case. Okay, so the density of the unknown. I believe the first one I did in the video, it smells like vinegar. So our density should be really, really close to that of vinegar or acetic acid. Okay, our unknown liquid 2, it's going to go through the same process. Our mass is going to be the mass of the liquid and the graduated cylinder minus the mass of the graduated cylinder. The volume we're going to read from the graduated cylinder. Okay, we get that information from the video. And the density of our unknown. So the density of this unknown should be really, really close to the density of rubbing alcohol or isopropyl alcohol. If you have any questions, feel free to reach out. Thanks, and have a good night.